Welcome to Kactus2. This tutorial covers the basics of the bus and abstraction definitions. We will begin by creating the bus definition. When creating a new bus definition, Kactus2 simultaneously creates a linked abstraction definition. A bus definition is used to describe high-level aspects of a bus, while the abstraction definition describes the low-level aspects. The created bus and abstraction definitions can be found in the library. Here we can see the newly created bus definition. The VLNV is displayed here, alongside the file path and description. On the right side are the extended bus definition and constraints for the bus. Extending means inheriting the mechanics from another document of the same type. The system group names contains the list of available system groups for ports in the affiliated abstraction definition, which leads us to the abstraction definition editor. Let's unlock the document to make it ready for editing. Similar to the bus definition editor, the VLNV and description are displayed on the left side, while the extended abstraction definition is displayed on the right. Under that is the associated bus type of the abstraction definition. The logical ports can be edited here. The editor is separated into wire and transactional ports. This abstraction definition needs a few logical ports, so we will create them here. A new port can be created by double-clicking in the editor, or through the right-click context menu. A single port can contain an initiator, a target and multiple system signals. In order to create a new signal for a port, right-click it and select the desired signal type. The bus definition and abstraction definition are now finished and ready to be used. In this part, we will use the created bus definition to create bus interfaces for components. This is the hardware design. We have 3 components and an incomplete bus component. In order to connect these component instances, we will create bus interfaces for them. Let's start with the component instance core 0. The document must be unlocked to allow editing. A new bus interface can be created by double-clicking in the editor, or through the right-click context menu. The bus definition can be set by dragging it from the library, and Kactus2 automatically selects a matching abstraction definition. The abstraction definition can be edited, and a bus interface can have multiple abstraction definitions. The logical ports of the abstraction definition must be mapped to the physical ports of this component. First, we add all the logical ports to this interface, then use the Auto Connection tool to automatically connect them to the physical ports of this component. The Auto Connection tool uses the name, direction and width of the logical ports to find matching physical ports, so it works well in this case. If the Auto Connection fails, we can always select each physical port manually. The external memory 0 and some buffer 0 will receive similar bus interfaces, but instead of the initiator mode, we will use target modes. For the incomplete bus component, we will create 3 bus interfaces, a mirrored initiator and 2 mirrored targets. The Target 1 interface uses similar ports as in Target 0, so it is better to connect the ports manually. A channel will be created between these interfaces, which allows us to connect them internally. The interfaces are now complete and ready for the design. In this part, we will connect the bus interfaces. Remember to unlock the document before editing. With the channel in place in the HIBI component, we can create a bus instance from it. We can then use the connection tool to create connections between the bus interfaces. The possible endpoints for the connection are highlighted. A connection requires that the bus interfaces have the same bus definition and have compatible modes. This is how the bus definitions work in Kactus2. Thank you for watching this video. For more information on Kactus2, please see the other tutorials.